Hello and welcome back everyone to lesson 2 of an introduction to Alice 3. Today's focus is control structures. We perform many different actions every day. For example, we wake up every morning, brush our teeth and dress for school. It is important to perform some of these actions in sequence where one action follows another. We might brush our teeth and then dress, but we cannot do both at the same time. Similarly, in algorithms, we have a set of instructions that should be executed in certain sequences. There are other events, however, that can occur together or simultaneously. For example, if you are in a hurry, you can eat your breakfast as you get dressed. Have you tried that? I'm sure you have. When you do some actions together, they are called simultaneous events. In Alice, we model a story and then think of the various events it should have. Next, we break down these events into simple instructions. Control structures help us arrange and execute these instructions properly. So let's have a look at what our main focus is. So we know the session's about control structures. Let's see what our objectives are for today's session. So our objectives are developing skills in Alice 3, and in order for you to be successful in today's session, you should be able to differentiate between sequential and simultaneous actions, define control structures and their importance in programming, use the do-in-order control structure and create a scene in Alice. So if you do the do-in-order control structure, if you use that today, you should be able to create a scene then. So meeting one of them will ensure that you meet both of them. The keywords associated with today's session are control structure, which is a statement that controls the execution of a set of instructions. Do in order, which is a control statement that tells Alice to execute instructions sequentially, which means one by one. Do together is a control statement that tells Alice to execute and run instructions simultaneously, which means side by side. Nesting refers to when one program statement is written inside another one. These two or more sections can work together or separately in many different combinations. And trial and error is doing frequent adjustments in the program to get the best results. Sequential and simultaneous actions. Sequential is succeeding or following in order while simultaneous is occurring. So consider the following example below. We do this many times a day. Walking. To take a step, you move your left leg forward and your right leg backwards. At the same time, you swing your right arm forward and your left arm backwards. For the next step, you move your right leg forward and your left leg backwards. At the same time, your left arm swings forward and your right arm swings backwards. You can say that we move our two legs and two arms simultaneously. A simultaneous action is the opposite of a sequential action. So a sequential action is where one action happens at a time. To take several steps, you move one leg forward and then the opposite leg. It is not possible to take both steps at the same time. So taking multiple steps is a sequential action. Sequential and simultaneous actions are important. And when I say important, I mean very, very important in programming. And the reason for this is because some actions happen simultaneously while others happen in sequence. These are two different yet relevant actions. Control structures, the main focus of today's session. A program consists of both sequential and simultaneous events, and we discussed the importance of these in programming in the previous slide. These events could be executed repeatedly. Sometimes an event will be carried out only if a certain condition is met. When writing programs and designing games, we must recognize these different events. We should also determine how to implement these events. To do this, we use control structures extensively. Control structures was one of our main keywords for today's session, and it's basically a statement that controls the execution of a set of instructions. Now, a few examples of control structures are sequential execution using the do in order command. We've got parallel execution using the do together command. Then we've got conditional execution using if-else statements and repetition using count and while commands. In this chapter, we will study the structures do in order and do together. Later, we will learn about the other structures. Your first task of this session is the do in order task. So control statement that tells Alice to execute instructions sequentially. By that I mean one by one. So what I want you to do is use a camel family scene you have already created from lesson 1. Make one of those camels, you choose which one, move in a square as if it's looking for food. So to move the camel in a square and ultimately return it to its starting point again, we will make the camel repeat these actions 4 times. And the algorithm that we are going to use is do in order, camel moves 10 meters ahead, camel turns 90 degrees to the left. So as you can see on the right hand side, I've got the instructions there. You need to select your camel, which one are you going to use? Then drag and drop the do in order command and then apply the blocks. Do in order task. To begin with, I need you to load up the camel family scene that you did in lesson 1. So to do this, you need to go to File, Open, locate the file and select Open, or go to Recent Projects and select it from there. If it's not on there, you select Open. Once you do select Open, your camel family scene should appear. Some of you added additional blocks of code, which is fantastic. So if that's the case, you will need to choose a camel that does not have any code inside it. So once you've found the camel that you want to program in today's session, you need to select it, like I have done in this example, and then drag the do in order text to the editor. Once you've done that, you need to drag and drop the move command into the do in order box. So this is the command that I'm going to drag and drop into the do in order box. And the next step would be to drag and drop the turn command. So as you can see here, orientation, drag, drop, and then we want it to turn left 0.25. I'm using 0.25 here, but what I would like you to do before you do choose 0.25, play around with the other settings and see what happens. So once you've done that, you can play your animation by selecting run and see what happens. So as you can see, this camel's going forward 10 steps and then turning. So as we mentioned in the task, we need to do this 4 times. So as you read this code to yourself, this .camel4, so it's referring to this baby camel here, move forward. I see 10 steps for duration 2 seconds. Then this camel turn left 0.25. So we need to do this 4 times. So a trick here is copying it to the clipboard and then pasting it into the do in order box, or you can just manually drag and drop the script blocks into the do in order box. I'm going to use a copy and paste. So right click on the first command, copy to clipboard and then drop it in. Same again with the second one, copy it to clipboard and then drop it in. So this one will need to go after that. So as you can see now, we've got 4 commands in total. So your animation should look like this. So moves forward, turns left, and then moves forward, and then turns left again. So we need to do this again 2 times. So right click, copy to clipboard, drag, and drop. Right click, copy to clipboard, drag, and drop. And then test your animation to ensure that you're doing it correct. Also, whenever you do insert 2-3 scripts, or should we say blocks, it's good to test to see if you have any errors or not. Again, once more, copy to clipboard, drag and drop, right click, copy to clipboard, drag and drop. Now test your animation. Well done, you have successfully used the do in order command to make a camel move in a square as if it was looking for food. The next step would be to take a screenshot of your code and your scene and save it and upload it to show my homework. What I am looking for. The main task for today's session is for you to create a scene with a train, railroad, train station and ramp as shown below. So as you can see this screenshot here, that's what I am looking for in terms of your scene. I want you to write instructions to make the train move smoothly on the track, climb the ramp and then head to the station. The train should not move off the track. So in order for you to be successful, you need to create a new scene, add objects, create the animation, run the animation, save it, take a screenshot of your code and your scene and upload it to show my homework. Top tip before you begin is writing and testing animations can cause a heavy load on your computer. So sometimes this can crash the system. When this happens, you can lose your unsaved work. To avoid losing your work, save your work every 10 to 15 minutes. You should also keep a backup on a flash drive or online. So before you do attempt this task, I won't be going through this task, but I will be showing you what I've done personally to give you an idea. But it's not a train and it does not have a ramp. In this example, I've used do in order combined with the move and turn script blocks. So for your task, that's all you will need to use. So let's have a look. So for your task, you need to create a scene with a train, railroad, train station and ramp. You need to write instructions to make the train move smoothly on the track, climb the ramp and then head to the station. The train, like my car, should not move off the track.